the Arctic. 66 million years ago, the world of snow and ice is home to dinosaurs. But dinosaurs aren't supposed to be able to live in such cold climates, are they? And these vibrantly colored animals are not the familiar image of dinosaurs we know from the movies. And how about a dinosaur that uses bugs as bait to catch fish? Were dinosaurs really that smart? Humanity has only known about the existence of dinosaurs for a little more than 150 years. Now our picture of their appearance and behavior is being radically redrawn. Yes, it turns out that the world of dinosaurs is even more amazing than we thought. Our new understanding comes from the latest discoveries made by researchers across the globe. Vividly rendered in computer graphics to bring the world of dinosaurs back to life. Dinosaurs ruled the Earth for a remarkable 150 million years. What was the secret to their extraordinary success? Scientists now think feathers played a significant role. Feathers may have given the dinosaurs a revolutionary advantage. Today, we journey back in time, back to the age of the dinosaurs. Our first stop is the Gobi Desert in Mongolia. This is known as one of the richest dinosaur fossil sites on the planet. 50 years ago, in this desert, a curious fossil was found. Here is that famous fossil. 2 giant arms. Each a little over 2 meters long and tipped with gigantic 30-centimeter long claws. From the shape of the bones, experts concluded this was a relative of Tyrannosaurus rex. But extrapolating from the size of the arms suggested a creature triple the size of T-Rex. A monster 30 meters long.
This dig attracted attention from researchers in the field of dinosaur studies, drew much interest and surprise, because no digs of carnivorous dinosaurs ever excavated in the past had such huge arms as these.
It was given the name Dinocheirus, meaning horrible hand. Ever since, scientists have been hunting for the rest of the skeleton to shed more light on its true form. It's been discovered, and now a complete skeleton of Dinocheirus will be assembled for the first time. Yoshisugo Kobayashi of Hokkaido University was part of the team that discovered these fossils.
We have seen it in bits and pieces, but this is our first time trying to assemble the complete skeleton. I can't wait.
Here, they assemble 100 pieces to get a full glimpse of the huge armed dinosaur for the first time ever. 4 hours later, the whole skeleton has been laid out. This is Dinocheirus. It turns out that the Dinocheirus was 11 meters long, far shorter than 30. The giant arms are far out of proportion to the rest of its body. A dinosaur of unbalanced appearance. In addition, though it's supposed to be carnivorous, it had no teeth. So how did it eat? Another unusual anatomical feature is now evident: a huge sail along its back. In the 150-year history of fossil hunting, no dinosaur like this has ever been found. It's far beyond our common understanding.
Our new discovery gives a complete and mind-boggling picture of the Dinocheirus.
What was life like for this outlandish-looking dinosaur? Based on the latest research, we reconstructed its appearance and behavior. To travel back to prehistoric Mongolia, a flourishing habitat for dinosaurs, and watch as the dramatic life story of one Dinocheirus unfolds. Although today the Gobi is desert, long ago it was lush with vegetation and rich with wildlife. Herd of Aviminus. Colorful feathers cover their 2-meter-long bodies, just like birds. A larger species of dinosaur comes running right behind them. It's Dinocheirus with its long arms. Dinocheirus also has a full coat of feathers. Recent fossil discoveries reveal that there were far more feathered dinosaurs than previously thought. One, two, three. Looks like a whole dinosaur family, plus a smaller one running behind. A bite has been taken out of its sail. It appears the Dinocheirus family is chasing after prey. Things are not always as they appear. They are the prey being chased too, by a 10-meter-long carnivore called Tylosaurus. This species preys on Dinocheirus, and 4 of them are after the young straggler. The pursuing Tarbosaurus are unable to descend the steep cliff and go after the remaining Dinocheirus family. Now, this young Dinochirus is alone and must fend for itself in this dino-eat-dino world. We now know many dinosaurs were feathered. The first fossil specimen of feathered dinosaur was found in China in 1996, called Sinosauropterus. It was about 1 meter long. Notice the black markings that surround its body. Paleontologists realized that each of these lines was a single feather. Then, in 2012, a fossil of a much larger 10-meter dinosaur with feathers was found. Until this discovery, scientists thought it was only small dinosaurs that were feathered. But this fossil, from a large one, shows clear traces of feathers. It was a groundbreaking discovery. After that came further discoveries of many different feathered dinosaurs. Now, it's clear that they were. And feathers overturned long-held ideas about dinosaurs. They indicate that the dinosaurs were the ancestors of another clan of feathered creature, the birds. Birds are the descendants of dinosaurs, their living legacy. Before these discoveries, scientists thought dinosaurs were scaly, cold-blooded animals, like lizards and snakes. Cold-blooded animals cannot maintain high body temperatures without sunning, meaning they can't move quickly in a cold environment. But birds are different. They're warm-blooded. Feathers help them maintain a stable body temperature, so they can be active at any time of day or night. Feathered dinosaurs, the ancestors of the birds, may also have had colorful feathers, and these feathers should have enabled them to maintain a stable body temperature. The weird-looking Dinochirus was also a member of the feathered dinosaurs. The fossil also gives a clue to their life. Curiously, its stomach was filled with rocks.
These are not just ordinary rocks. They are called gastroliths. The dinosaur swallows them intentionally.
It's another weird fact about Dinochirus, a body suggesting a carnivore, but with no teeth. But these rocks in its stomach reveal what they ate. Let's return to the Mongolian plateau of 66 million years ago. There's the orphan juvenile Dinochirus. It's eating leaves. This carnivorous-looking dinosaur is actually an herbivore. Having no teeth, Dinochirus gulps food down, unchewed. Then the gastroliths in its stomach grind up the food for digestion. The Dinochirus begins roaming around in search of food. A smaller dinosaur pops out of a tunnel in the ground. It's a Protoceratops. Recently, a fossil of a protoceratops was found trapped inside a tunnel. Den-dwelling dinosaurs. Once again, a find that upended a long-held idea, that dinosaurs did not burrow. Alone, she arrives at the shore of a lake. She's joined by a small white dinosaur. One was just discovered in 2017, called Hulshka-raptor. It specializes in diving. Dinosaurs that dive underwater are another major recent discovery. Based on their body features, scientists believe they maneuvered underwater to snap up fish. In fact, Dinocheirus fossils have been found with fish bones inside their stomach. It can catch fish with a swipe of its arm. Those big, awkward-looking arms prove their usefulness. Dinocheirus evolved from carnivorous species, but gave up eating meat for a diet of plants and fish. The first known omnivorous dinosaur, Dinocheirus, really is weird and wonderful. Even though she's all on her own, she seems to be making her way in this world of dinosaurs. Feathers did not only make dinosaurs colorful and help them keep warm, they also made possible another great change. For more on that, let's consult Kohei Tanaka of Tsukuba University. Tanaka is a dinosaur expert, of course, but his research focus is a bit unusual. It's what's here in his hand, pieces of dinosaur egg.
Fossilized eggs contain a lot of information about reproductive behavior, rearing of offspring, and so on. I like eggs more than bones.
What do eggs have to do with the dinosaur's feather revolution? The fossil that provided a key clue was found in China. Today, with special permission from the museum, Tanaka is examining the precious fossil directly. Dinosaur eggs. But apparently conspicuous is their size. It's a set of huge eggs, 40 centimeters each, laid in a ring formation. They belong to a species of oviraptor, a fairly close relative of Dinocheirus that was also a large-sized feathered dinosaur with an 8-meter-long body. Tanaka says that this fossil is proof that dinosaurs used feathers to make a big change in their behavior. But how does a donut-shaped ring of dinosaur eggs relate to feathers? Let's head back to the age of the dinosaurs again. Mongolia, 66 million years ago. The Dinocheirus orphan has survived and has grown much bigger. and her feathers have turned redder. Scientists say it's possible the dinosaur down and feathers may have changed color as they matured, like modern birds. Now another Dinocheirus approaches. This one's neck and sail are blue. It seems to be a male. Feathers may have also been useful to visually distinguish the sexes. The male raises his head and spreads his long arms. It's a mating behavior. Like modern birds, plumage could have also been important in mating. Sometime later, our survivor is squatting on the ground. Beneath her is a clutch of eggs. A breakthrough made possible by feathers. Like modern birds, feathered dinosaurs sat over their eggs to keep them warm. But this dinosaur nest has a clever feature not found in birds' nests. The arrangement of the eggs in a donut-shaped ring.
The dinosaur that laid these eggs was quite large, so to avoid trampling on its own eggs, it left an open space in the center of the circle where the parent could sit without crushing any eggs. Then, using the feathers on its arms, perhaps, it kept the eggs warm. It incubated them.
This behavior is exhibited by many birds. By covering them with feathers, the parent can keep eggs at a stable temperature, so that eggs can be hatched even in bad weather and cold climates. From fossil evidence, researchers thought many smaller feathered dinosaurs may have incubated their eggs as modern birds do. But it was long believed that large dinosaurs did not, because of the risk of crushing their eggs. However, this fossil clutch showed some larger feathered dinosaurs could also incubate their eggs by cleverly avoiding that problem.
This is a fantastic specimen, as it shows how dinosaur parents cared for their young.
Tanaka believes the Dinocheirus also incubated their eggs using their large feathered arms. By regularly shifting its seating position to cover different groups of eggs in turn, it may have kept them all warm. This led to higher rates of hatching than leaving the eggs alone. By keeping close to the eggs, the parent dinosaur could also protect its offspring from predators. A A small carnivorous dinosaur species called Xenobazer lurks in the background. They want to feast on the eggs. One of the Xenobazers sneaks past her defenses. By the time she notices, it's too late. Based on the size of the eggs, the incubating period for Dinochirus was probably 90 days. The hatchlings are about 50 centimeters in size. She was once an orphan. Now she's a mother. With the help of feathers, dinosaurs could be more active and mobile. They gained the ability to incubate eggs and greatly increased their hatchling rate. This was the Feather Revolution. It propelled the dinosaurs to expand their habitat range into further reaches of the globe, and even colonizing a region where scientists had long believed it would be impossible for dinosaurs to survive. The Arctic. A recent series of fossil finds have revealed that many dinosaurs did inhabit the Arctic year-round. It's early winter in the Arctic. Temperatures can plunge to a freezing 20 degrees Celsius below zero. This is a herd of Pachyrhinosaurus. They're 7 meters long. Recent fossils have been found which indicate that Pachyrhinosaurus had feather-like fur. The covering of bushy fur would have made living in snowing conditions much more feasible. The harsh Arctic was also home to a species of feathered dinosaur just as revolutionary as Dinochirus. Called Troodon, it adapted to life in a frigid climate by acquiring an unusual capability. They're thought to have some kind of intelligence. Troodon is believed to be the most sophisticated of all dinosaurs. What made Troodon so smart? Lawrence Whitmer of Ohio University in the US figured it out. Based on Troodon's skull fossils, he created this 3D model. The size of the brain is shown in blue. When we compare its brain for skull ratio with that of a Tyrannosaurus, Troodon's is 3 times bigger. Whitmer believes it had the biggest brain in the dinosaur world. He said feathers had a considerable influence on the development of a big brain in dinosaurs. The key factor in it is brain energy consumption. That is, the brain is a very energy-hungry organ.
The evolution of feathers provided insulation that allowed them to evolve endothermy, which may have been very important for them to develop large brains and high intelligence. As a result, they actually need bodies that can feed the brain, and so the feathers and the endothermy contribute to the agility and the ability to capture all that food.
Thanks to feathers, Troodon could inhabit the frigid cold Arctic, and there they further developed their brains to adapt to smarter survival behaviors. Troodon uses its intelligence to survive in the harsh conditions of the Arctic. The Troodon male comes across a fallen log. He knows where to find bugs at this time of year. But he's not swallowing it. Why not? With the bug in his teeth, he heads over to a nearby stream. And now, a fish is lured in by the bug. He is fishing. This behavior is found among modern herons. It's possible Troodon may have used this strategy too. A small bug wouldn't have been a filling meal. Troodon may have used its intelligence to turn small bugs into bigger prey. Such smart behaviors may have greatly helped them survive. The next day, the weather has turned rough for the Troodon. When a storm hits here in the harsh Arctic, animals hunker down. When the blizzard lets up, he'll need a smart strategy to get a meal. Quickly, he digs the ground. In fact, he's buried these nuts himself in the fall. This food stashing behavior is observed in modern birds, like crows. But while the Troodon is busy feeding, an enemy stalks him. It's a Dinosaurus, the apex predator of the Arctic. the Nanosaurus also uses its brain to survive in the harsh Arctic. He drives the Troodon out onto a snowy plain with no place to hide. It's a life and death battle of wits. The pressure to survive in the harsh climate surely pushed Troodon to boost its intelligence. Deep winter is almost here. His highly developed brain is his weapon to fight through the dark, brutal winter. The idea of dinosaur intelligence arose from recent discoveries about the high intelligence of birds, the descendants of dinosaurs. Let's watch a demonstration of bird intelligence by this parrot. The tiny basket inside this tube contains nuts. The tube sits on a table along with a pipe cleaner and a string. The parrot picks up the pipe cleaner and deftly bends the tip of the wire. Now it flips the wire around and uses it to hook the basket. Recent research has revealed that bird brains are twice as dense with neurons as mammal brains. This enables some birds to have intelligence comparable to a human child.
We don't really know whether Troodon had that kind of brain structure, but if it did, that might suggest that Troodon might have had the kinds of behaviors that are fairly widespread in birds, that all of these dinosaurs may have had some kind of intellectual capacity, the intelligence that we see in many birds today, which in turn may have provided the ability to have the high intelligence and the behavioral complexity. So everything may ultimately come back to the evolution of feathers and feather-like structures in dinosaurs.
Let's return to the Troodon in the Arctic of 66 million years ago. It's spring now, and the winter snow is melting. A herd of Pachyrhinosaurus is agitated. What's going on? A group of Troodon. They're confronting the herd. But Pachyrhinosaurus are herbivores. They wouldn't attack Troodon. So why are the Troodon trying to drive them off? Nearby, there are more Troodon, incubating eggs. Our Troodon and his group prevented the Pachyrhinosaurus from trampling their eggs. Just as in modern birds of similar size, Troodon males may have incubated the eggs. He heads back to his nest. His own eggs are broken. Did a predator make it through after all? Hatchlings. They must have hatched a little earlier than the other eggs. Now, the Troodon has something he wants to teach his offspring. Fishing. He's passing on hunting techniques to his offspring. One immediately tries to imitate him. The techniques he passes on will help more of his offspring to survive in this harsh environment. Feathers also paved the way for such caring dinosaur family traditions. Back in Mongolia. The Dinochirus is a mother now, busy raising her brood. She and her young are in the midst of feeding. She may have taught them which plants are edible in this way. Tragically orphaned when young, she has made it to this fulfilling stage of life. But the predators that took her family are still out there. Again, a Tarbosaurus attacks her. Using her long arms and sharp claws, she fights back ferociously to protect her young. And manages to drive off the Tarbosaurus. The dinosaurs reigned on Earth for more than 150 million years by caring for and fiercely protecting their offspring. Feathers not only transformed the dinosaurs physically, but also mentally. This is the picture of the amazing world of dinosaurs, supported by the latest research. Land that was roamed by dinosaurs is now roamed by researchers who are seeking clues left behind by the dinosaurs.
There were probably hundreds of thousands of dinosaur species, perhaps millions. But we have only found about 1,000 species to date. It's like all we've done is chip away at the edges of a glacier. There are so many yet unknown, unique kinds of dinosaurs out there. But we will keep finding more of them.
Today, we're finally starting to glimpse what the world of the dinosaurs was really like. The amazing Dinoworld is still a vast and barely explored frontier of the history of life on Earth.